Welcome to Leaseweb Tech Talk, the podcast exploring tech landscape, cloud hosting, and IT infrastructure. Whether you're a professional or new to tech, Leaseweb Tech Talk got you covered. Join us for latest trend, business cases, insightful interviews, and useful tips. Welcome to Leaseweb Tech Talk. I'm your host, Pamily and today we are taking a journey back in time to explore the fascinating history of digital data storage. And with me today, I have Gabriele Zanon, who is the Cloud Storage Product Manager here at Leaseweb. So Gabriele, I hope you're having a great day. And I am very curious, and I hope my listeners are too, to understand how we went to cloud storage all the way from punch card.
Hello, Pamely, and hello, everyone. And as you say, this is a really fascinating story. I mean, it's beautiful with many achievements and many milestones. Too many to cover in a short amount of time. And
all about like 100 years, the whole century.
At the very beginning of the 19th century, actually, because Joseph Marie Jacquard used the punch card for the very first time back in 1801 and used it to automate textile loom in order to give commands for complex weave patterns.
Okay.
So that was the very first example of automation with a punch card, which was literally just a sheet of paper, and you punched holes in specific points to give instructions to the textile loom. Now, and that was used for a very long time. Then, if you want to fast forward a bit, in 1889, the very first use of a punch card in an electromechanical machine, that was done by Hermann Hollerich. He was an American inventor born by German immigrants, and they had to automate the US Census of 1890. So he used the punch card and he built an electromechanical tabulating machine to read this punch card in order to catalog the citizens. So that was the very first beginning of the binary era, because if you think about it, the holes that you put in the punch card are exactly like the bits, 0 and 1.
Yeah.
And it was the very beginning of the binary era and of semi-automated data processing. So that's the very beginning of this. Later in time, of course, the main problem of the punch card was the limited amount of data that you can input on these cards, because unless you have a gigantic piece of paper, which wasn't possible for the time.
But was it like the size of A4 paper? How big are we talking about the paper?
They're probably smaller than even than an A5, like a postcard. They were different sizes, but anyway, that was more or less the standard. But in any case, there were two major problems at the time. First of all, the size and the quantity of data that you contain inside that. And the second point, the fact that you can only use it once.
Yeah.
Once you punch a card, that's done. You cannot modify it. To solve these problems, we arrive in 1928. A German engineer named Fritz Flümer tried to solve the limitations of a punch card. Okay, so limited amount of data and non-reusability. So he took a string of paper, coated with iron oxide powder, and managed to magnetize it. He based this on a previous prototype of 1898 in Denmark. When they magnetized a steel wire, he just did it with a string of paper, because you could easily roll it, and you can easily put data on a string of paper rather than a steel wire. The purpose was to record audio on it. And the main advantages of this, of course, you could use a very long string of paper that when you put it together, you could store more data than a punch card. You could also roll it to occupy less space. But the biggest advantage, since it was a magnetized string of paper, you could erase it and rewrite it.
Oh.
This was a big revolution for the time, because if you think about it, it was the very first time that you could reuse the media. The music cassette was born like that, and he collaborated with AEG to produce the very first tape recording, the Magnetophone K1. It was exposed for the first time in 1935 in Berlin. And this was the biggest revolution you can think about it, because music cassette was born. Then VHS, magnetic tape, is used today with LTO to record data, with of course much higher density and higher technology, but the principle stays the same: it's magnetized tape. It was a very big revolution for the time.
And it happened immediately after First World War, right?
Yes, and also because of the war at the beginning, this technology of magnetic tape was kept partially secret. That's why we had to wait till 1935 to be exposed publicly.
Okay.
But it was in any case a very big revolution. And again, we meet limitations. Again, it was the quantity of data. That was the first limitation, because the needs of the industry were growing and growing and growing, because first was used for audio, which occupies a certain amount of data, then for video, which was a much bigger amount of data. But there was one particular problem. Since the tape is linear, you need to fast forward or rewind if you want to get to a certain point and read a specific data. Now, that was a problem. Before solving this problem, which arrived later in 1956 with the magnetic disk, magnetic tape was used for the first time in computers in 1951 with the UNIVAC 1. This was a gigantic device that occupied a space much bigger than this room, weighed more than 12 tons and requiring more than 120 kilowatts of power. And he was using multiple tapes. And he was able to perform roughly, less than 2,000 operations per second. Today my watch can do better. Today my watch can do better than this, but it was revolutionary for the time. And 2,000 arithmetic operations per second were a lot. But in any case, one problem remained. Again, you need to rewind or fast forward the tape in order to access to a specific data. This was solved in 1956 with the arrival of the magnetic disk. The magnetic disk was basically a magnetized disk, was very large, like 24 inches, so it was large, and a mechanical arm was hovering over it and read the data. The advantage, of course, you don't have to rewind anything. You can just move the arm, spin the disk in a certain position, and you're going to read the bits in order to retrieve data. This increased dramatically the speed, the access speed of data for the time. And this was, if you think about it, the birth of the spinning disk that we still use today.
Okay, but not in the same shape and form.
Not in the same shape and form, exactly, because like I said, the very first magnetic disk was 24 inches wide, and which is not a size you can fit in a personal computer today, and for sure not in a laptop. Again, to also at the time there was not enough technology to increase the density of the data. So at the beginning they increased the size of the disk. The beginning was 24 inches, then became 26, then 29, and became bigger and bigger. And this happened until the 1973 with the arrival of the Winchester disk drive. This new technology that allowed a much higher density in a much smaller space. And this paved the road to the personal computer, because thanks to this technology, the disks became smaller and smaller. Began with 8 inches, then 5.25 inches in the 1980, 3.5 inches in 1983, which is the size we use today in a lot of our personal computers. And in 1988, we arrived to 2.5 inches, which is the form factor we use in laptops today. And again, spinning drive. So imagine the technology that was evolving to miniaturize more and more the drives, the rotor, the spinning, and the access speed became faster and faster. The rotation of the disk reached numbers that are familiar to many engineers, like 5,400 rounds per minute, then 7,200, 10,000, till arriving to 15,000 rounds per minute on SAS technology.
So it means that the size of the disk got smaller, but the capacity kept increasing.
Yes, because they managed to increase the density of the disk, because the very first magnetic disk, just like the magnetic tape, were a disk coated in iron oxide powder. Today, of course, we use better technology and different materials to magnetize disks. And thanks to that, we increased we increased the capacity because we went from the very first magnetic disk who contained 5 megabytes of space, that for the time was a lot. And today, when we contain even 30 terabytes in a single drive, which is exceptional. But again, there was another problem with spinning disks, that the access speed to data was limited to the speed of the on how the mechanical arm could move and could hover the plate. If you open a disk and you watch the mechanical drive moves, it's so fast that you cannot discern the movement with your naked eye. But it's still a mechanical movement. The problem with the mechanical arm was solved later in time with the introduction of solid-state drive technology.
Okay.
The solid-state drive technology replaced the mechanical actuator and the spinning drive with electromagnetic cells and an electric controller in order to read the data. So there was no longer a physical movement in order to read the data. Of course, it was more expensive, but of course, it allowed for an incredible increase in performance. A standard spinning drive can perform today around 160 to 200 operations per second. A solid-state drive can perform 50,000 to 100,000. And now the new generation of solid-state drive, which is NVMe, non-volatile memory express, can even reach hundreds of thousands of operations per second in a single drive, which is eclipsing what we were doing before. But if you think about it, it is the culmination of the evolution of our storage. And it's also interesting to discuss about on how mobile storage evolved, because until now we spoke about the hard drives, which was you can find in every personal computer and laptop, but at the same time, portable storage was also necessary because they were very heavy, and you need a laptop in order to read it. You could not simply extract it and move it. Yes, you could, of course, but with a lot of technical difficulties. This is how floppy disk was introduced in the 70s. Again, in a similar form factor of the hard drive, 8 inches, 5.25, 3.5. They were the main advantage, despite the fact that you could contain much less data, but they were very inexpensive, easy to use, and very durable. I mean, we have floppy disks that are still readable today after 30 years, which is amazing. Then the technology evolved beyond the floppy drives with the CD and the DVD, something that many people experience.
And also the movie tapes.
With the movies, we had to wait a bit more with HD DVD and then the Blu-ray, because of course at the beginning the CD could contain around 700 megabytes, which was a lot for an optical media. Plus it was a plastic material, so it was very flexible and durable. With increasing in density, with the HD DVD and Blu-ray, we could store HD movie or even 4K movie.
Yeah, that was the childhood with a tape and watching all the cartoons and the movies.
In the 90s, the dream of every teenager for Christmas was the portable CD player.
Exactly.
That was the dream of every child back then.
Every millennials out there can relate to you what you're saying.
Exactly. The CD industry and the DVD industry and the Blu-ray industry is still active today. However, we are assisting to a decline on this, despite being a good media also for archiving, if you think about it, because there is also archiving on CDs and DVD and Blu-ray, and Sony introduced the optical disc archive as well
that was Sony who introduced that.
Yes, absolutely. That was an amazing technology for archiving media on optical drive, a technology that could last the media for more than 100 years. It was an incredible engineering achievement on an optical media. But in any case, for the mass distribution and the arrival of the streaming services with the introduction of cloud storage, because of course the main problem at the time, there was not enough connection to an internet bandwidth to sustain mass distribution. With the arrival of this parallel technology, we managed to put our storage on cloud, and that's when the streaming services were born, and this brought the inevitable decline of the portable media storage. Because if you think about it, when was the last time you downloaded a song or a movie on your computer. You usually open Netflix or Spotify, and you select what you want and you listen it, but you do not keep it locally.
But that whole revolution happened towards 21st century, right?
Yes,
Yeah.
That's of course a recent history. And
Only Gen Zs can relate to this part of yours.
Exactly. That was the transition from the pure stream to the pure streaming era from the physical device era, which anyway it's still active today because many people still prefer to have a local copy.
Yeah.
And this is the evolution of the storage until today. Like I said, there are many more milestones that I didn't mention because, for example, before arriving to the Winchester drives, there were many more iterations with many more attempts. And one thing that we've seen today to understand what the future has in store for us, of course, every single one of us knows the name artificial intelligence. The generative artificial intelligence is now exploding with data.
Yeah.
Today we are producing more data than we can actually store. The industry is having difficulties in keeping up with the production of hard drive, which of course involves physical space where to place this hardware, power consumption, and all the related issues. That's why there are a lot of researches in order to find new ways to store, archive, access data, and distribute it. There are two that are worth mentioning in this tech talk. The very first one is the storage over DNA. Storage over DNA is a fascinating topic that will require days in order to properly explain, but to summarize in a simple way for those who are listening to us, if you think about it, DNA is the original storage. Okay, it collects information on who we are, how we are, and this is present in every single living being today.
Yeah. It's a very interesting term, storage in DNA, because you will always take it in a biological way. It's like, oh, DNA.
Yes, but if you think about it, DNA is a code with the famous A, T, C, G that they can be converted into bits.
Okay.
And DNA, the theoretical point of storing that into DNA began way early in the 1960s, and they started to experiment in the 1990s. And researchers back in 2019 already managed to store data into synthetic DNA in 2019. But why are they doing this? There are two main advantages on why you want to store data inside DNA. Number one is extreme durability. If you check any scientific documentary, all the discoveries that we made in the permafrost of organisms dating back 10,000 years, you can still read DNA. So imagine storing data, and that data you are sure that in 10,000 years from now it will be readable.
Okay.
That's the absolute epitome of durability for your data. And that's reason number one. Reason number two is its extreme density. You can compress DNA in an extremely small space, and they did some mathematical calculations about that, which is 200 petabytes, which is a space. If you use today's modern technology with drives, it will require you multiple racks in a data center. But if you store the same data into DNA, it will take you the same space of a small sugar cube.
That's fascinating to hear.
That's absolutely fascinating. And that's one of the technologies that they are studying in order to improve our capacity to store and deliver data. The second element that I would like to discuss on top of DNA storage is, of course, quantum computing. Quantum computing is extremely complex. It's something that will require us a lot of time to discuss, and there are many researches on quantum computing today. But the most basic concept I would like to transmit today is for the quantum storage and their usage of its basic unit, the quantum bit or qubit. Traditional storage utilizes bits, So you have your bit that can have two states, 0 and 1. Even in DNA storage, you can convert the A, T, C, and G of DNA, you can convert them into standard bits. Into quantum storage, you utilize quantum bits or qubits for short, and these can have any state between 0 and 1. So they can have, for example, 80% 0 and 20% 1 until the moment they are measured. So when you have, for example, 100 bits, that this should convert it to 12 bytes. So you can have a very small amount of information with 100 bits. With 100 qubits, instead, you can have so many possible states and so many variations of your data that you can store pretty much anything you want. And that's thanks to their property called superposition that allows quantum bits to have such variety in states.
So it's still a research and trial-based product,
yes,
right? It's still not at use.
Yes, before we will see any commercial application of quantum storage, I think many years will pass. But this is just this brief introduction to DNA storage and quantum storage is just to showcase how the technology for storing data is far from complete, and we keep finding new methods in order to store data, much more data in much less space and much higher speed, and consuming much less power. And this is an evolution that I believe will continue forever.
Thank you, Gabriele, for sharing such insight knowledge with us and taking us through the whole journey and evolution of this data storage. So tune in for the next episode where we will tap into more detailed cloud storage, and we'll speak about specific storage such as file, block, and object. And thank you so much for your time today.
Thank you.
We hope you found this episode insightful. For more content, like, share, and subscribe. You can also subscribe to our newsletter at leaseweb.com/newsletter.